This is 6.3 part 2. Writing words with logarithms, asking, make a guess as to what it might be, then evaluate it using your calculator. So, the question on like number 2 is, by the way, this is an ln. The question is, so an ln has a base of e, what power of e equals 99? So e to what power? If you like algebraic expressions, e to what power is 99? Man, I don't even have a good guess. E is a little close to 3, but it's pretty far off. Like, I know that 3 cubed is 27, 3 to the 4th is 81, 3 to the 5th is 243, and E's like 2.7, so I'm going to guess that it's close to 5, because E's a little less than 3. It's 2.72 roughly. So, answer it with a calculator. You got the natural log of 99. Not too far off. 4.5951. Over here, this is a power of 10, right? That's a log. 10s are understood. All right, solve the logarithm equation by converting into an exponential equation, and I gave you the setup here. It's all about log base b, argument a equal to e. And if you just see a log, you put a little 10 there. If there's no base given, you just put a 10 there. Now, this would be my base, that would be my argument, and that would be my exponent. Bases have exponents, and they equal the argument of the old logarithm. A 10 cubed is 1,000. Shame on you if you don't know that. 2 moves. We're going to add 1 to both sides. It's 1,001. And then we're going to divide by 2. So there's your x value. She's 1,001 over 2. If you want to write 500.5, so be it. All right. Probably should have done 4, but remember, put an e there and then take it from there. Isolate. It says always isolate either the log. It should just say always isolate the log before you do anything. Let's see here. Let's do 6. It says isolate the base of e before converting. Okay, so I'm going to add 2. That's going to give me 14. 4e to the 4x minus 1 is 14. I'm going to divide out that 4. E to the 4x minus 1 is 7/2. And now we're going to do the conversion. And the conversion is to identify your pieces and make her a logarithm. You have a base. That dude is the exponent because bases have exponents. They're up high, which means this is the argument. So I'm going to have a logarithm whose base is e. Her argument is 7/2. And she would equal the old exponent of 4x minus 1. Now log base e is ln. So we have the natural log of 7/2 equal to 4x minus 1. 2 moves, add 1 first, and then lastly divide by 4. That's my x value right there. Natural log of 7/2 over 4. That's what she is, kids. If you want to know what it is, you push buttons in a TI-84. Let's see here. Find the inverse. I should probably do at least one of these. So I'm going to put that little understood 10 there. This is y, and y becomes x. So we have a log base 10 of 3y minus 1. And it's actually a big deal that you put that 10 there. A lot of kids won't do it. You got to have it there. You do. Now that's going to be your, well, first off, too early to me to do what I'm going to do. I need to isolate this logarithm. So I'm going to subtract 3. X minus 3 equals a log base 10 of 3y minus 1. Now what we're going to do is we're going to exponentiate. So I'm going to identify my pieces. What I did is I isolated the logarithm. Forgive me for being tired. And I'm realizing what my pieces are. My base, my argument, and my exponent, which happens to be on the left-hand side. So I have a base of 10. My exponent is x minus 3. And I would equal the old argument, 3y minus 1. I'm going to add 1 to both sides. And lastly, to isolate y, I'm going to divide everything by 3. So 10 to the x minus 1 plus a 1 all over 3 is the inverse of g of x. Ta-da! It's not bad. For some. You still don't know how to do two-step equations. It's pretty brutal. Yeah, I'm not gonna do those. Got some old stuff here to help you on an upcoming test. Do 11. Certain pesticide kills 24% of all bugs every 11 minutes. There's the hourly kill rate. So I'm just gonna let my principal be 100%, okay? So the amount after time, and let me talk about our formula we're using. It is killing, therefore it is decaying. Is principal times 1 minus r to the t. So I'm gonna let my principal be 100. 24% is 0.24. 1 minus 0.24 is 0.76. And it happens every 11 minutes, so I need to introduce a slash 11. Now, the hourly kill rate, there's ways of manipulating this thing, but the easiest thing to do is just plug in 60 minutes. Yeah, I swear it is. And then go push some buttons. And this isn't going to give you the hourly kill rate. This is going to give you the amount remaining after 60 minutes. And that's what we have to understand, that this is what's left after 60 minutes. I'm going to rooftop that to the 60/11th power, which means you're taking the 11th root and then multiplying it by itself 60 times. It's about 22.3817. Now, actually, this is already a percentage. 22.38%, because this was 100%. Now, this is the amount remaining. That's what that is, the amount left, okay? Which means that we killed 100 minus 22.38, which is what, 77.62. And that is the amount killed in 1 hour, by the way. All right. I'm really torn. Like, should I let y'all do this or should I do it? If I don't do it though, none of you are gonna do it. It is so sad how little y'all try. Like, I don't mind working an extra hour or two a day. It's usually about two. But what bothers me is that y'all won't try. And some of you do, but most of you by and large don't. And if anything's gonna drive me out of teaching, it's that. I don't know how to fix apathy. I don't. It's kind of sad. Anywho, find all the zeros of this function. First, look at the graph and synthetically divide out enough zeros to reduce to a quadratic. So let's take a sneak peek of the graph here. The graph is going to give me some things I can work with. Yeah, y'all need to work on your apathy. Be really cool if you could help your kids one day. Mommy, I need help with my math. Awesome. I had Mr. Milbrath. I know how to do this. Just saying. I don't know if I need that 0 and y2 or not. Or daddy. You know, dads can help too. I help my kids all the time. So I am going to put a 0 back in y2 just to make sure that this is what I think it is. I think it's 1.5, but this is an old question. I don't honestly remember the answer to it. So now that I've got a 0 in y2, I can use the intersect feature. It looks like 1.5, and it probably is 1.5. You'll notice I'm pressing that left cursor to get close. Enter, enter, enter. And it is 1.5. And it's negative, of course. I wasn't saying the negativity. So from the graph, I know that two x values are x equals negative 1.5 and 4. And these, by the way, are zeros. These are zeros because they're also x-intercepts or roots. Now let's jump down here to this. This is saying that f of negative 1.5 is a 0. It's also telling me that f of 4 is a 0. Those are two of your zeros written using function notation. Now this is a fourth degree polynomial, which means it has 4 zeros. So what we're going to do is we're going to do synthetic division. And I'm just going to do the 4 first. Coefficients are 2, negative 5. I think that's a negative. Check that. Yeah, negative 5. -10, -5, and -12. And your acronym for synthetic division was DMA. So we're going to drop the 2. 4 times 2 is 8. -5 plus 8 is 3. 4 times 3 is 12. -10 plus 12 is 2. 4 times 2 is 8. -5 plus 8 is 3. 4 times 3 is 12. And we have a 0. And since I got a 0, I'm going to go ahead and do synthetic division again. -1.5 times 2 is -3. -3 plus 0 is 0. Anything times 0 is 0. 2 plus 0 is 2. And 2 times -1.5 is -3, and we got another 0. Now remember, this is your remainder, your constant, your x, and your x squared. So you have 2x squared plus 2 is a 0, because that's where the remaining 2 zeros lie, in that factor. So therefore, 2x squared is -2. Divide out the 2, x squared is -1. So x is plus or minus the root of a -1, which is plus or minus I. So f of I is also a 0, and I, by the way, is an imaginary number. And f of -I is also a 0. And that's where I'm going to stop. Boy, I just got hit with a wave of disorientation. There you go.